Hello everyone, welcome to PYQ's. This is question of IS 2014 on analytical geometry. This is first lecture on analytical geometry. So the question is from cone topic. So this is 10 mark question. Now we'll try to solve it. Examine whether the plane x plus y plus z equals to 0 cuts the cone yz plus zx plus xy equals to 0 in perpendicular line. तो सबसे पहले हमें एक प्लेन दिया हुआ है x plus y plus z equals to 0 और हमें एक कोण दिया हुआ है. तो first and foremost thing we can see, we'll write steps here first. So we can see both cone and plane, both that is cone and plane passes through origin. Okay. So origin से pass करते हैं. Next we'll take a line passing through origin, that is O. Line का equation x by y, y by b, z by c equals to r ले सकते हैं, where a, b, c are direction ratios. Now we'll satisfy the condition that plane cuts the cone in lines, and we'll apply that perpendicular, that is cos theta, as for two lines a1 a2 plus b1 b2 plus c1 c2 equals to 0 condition, to find out whether the lines are perpendicular or not. Okay, so let's try to solve it. For solving, as I said, both plane and the cone passes through the origin. So let the cone, that is, this is the required cone, this is the given cone, and it is O, and consider this is the plane, and these are the lines given in the plane which cuts the cone. So consider this be the point x comma y comma z, the general point, and DCs of the line as ABC. So general line passing through origin is x by a, y by b, z by c equals to r. Now if lines are in the plane, then the DCs of normal to the plane and the DCs of line should be multiplied and give to 0 because both are perpendicular. That means if we'll put a into 1 plus b into 1 plus c into 1 equals to 0. This is equation number first, because 1 is to 1 is to 1 is the direction ratios of the normal to the plane, and a and b and c are the direction ratio of lines. So we'll multiply them for perpendicular. Okay. The next question will be this point x satisfies the cone. So general point here is AR, BR, CR. This point should satisfy the equation of cone because this point lies on the cone in the plane. So this point satisfies this equation. So I'll put BR plus C here. So this is not here, BC. So I'll get BC plus CA plus AB equals to 0. So I've got these two equations. Now by solving these two equations, we can get the relation between direction cosines for lines. Then we'll examine whether these are perpendicular or not. So from these two equations, from first equation we can take A equals to minus B plus C and put in the second equation. By putting in the second equation, we'll get first one BC plus C times of minus B plus C and plus minus B plus C times of B equals to 0. Then we'll expand it. BC will be cancelled out, then it is minus C square and then minus B square and then minus BC equals to 0. So this will be equals to C square plus B square plus BC equals to 0. This can be written as b by c of whole square plus b by c, if you will divide by c square in whole equation, plus 1. So it does means if this quadratic has two equations, then suppose b1 by c1 and b2 by c2 are two equations, then multiplication of b1 by b2, b1 by c1 into b2 by c2 should be equal to product of roots of a quadratic equation equals to c by a, that is equals to 1. It implies b1 by b1 into b2 equals to c1 into c2. So that is equation number 3rd. Similarly, we can find a1 a2 equals to b1 b2. So this is equation number 4. So now from 3rd and 4th, what we are getting? We are getting as a1 a2 equals to b1 b2 equals to c1 and c2. So this is what we are getting. Now for cos theta, for angle between them, as a1 a2 plus b1 b2 plus c1 c2. So we can write it as 3a1 a2 or 3b1 b2 or 3c1 c2. So it does mean it will become 0 if and only if plane is either xy plane, or if line intersects in xy plane or xz plane or yz plane. So this is the condition when these lines will be perpendicular, otherwise these lines will not be perpendicular. So that is what we have to do, we have to examine. So that is all in this lecture. Thank you.